Dalgaları karşılayan gemiler gibi gövdelerimizle karanlıkları yara yara çıktık. Rüzgarları en serin, uçurumları en derin, havaları en ışıklı sıra dağlara. Hey, hey, hop, hop, hey, hey, hop, hop, hey, hey, hop, hop. Dostların arasındayız, güneşin sofrasındayız. Dostların arasındayız, güneşin sofrasındayız.
Hello, can everybody hear me okay? Thank you. Okay, I'm here today to talk about facility monitoring systems. You'll have a little bit of this subject covered by Matt in a previous presentation, so hopefully this follows on quite nicely. So with a monitoring system, there are some considerations you have to take into account. Firstly, the manufacturing technology involved. Is it a liquid fill application, powder fill application? Is it a manual operation inside a laminar airflow cabinet? Or is it isolated technology? You have to look at the sampling regimes to be adopted. We're talking about particle counting at this particular time. So is it going to be grade A, which is typically isolated? Is it going to be grade B, which is typically background operation, where you've got items such as filling lines which are open, or laminar airflow cabinets? You need to look at the operator interfaces for clean room personnel, because depending on what you're doing, those personnel need to know what the monitoring system is telling them. So you need to decide what's the best way of doing that. You also need to look at these cleaning and disinfection procedures you're going to use. The reason for that is some of the sensors may not be suitable for certain cleaning processes that you may employ. So just need to be taken into consideration. And you also need to look at maintaining production in the event of something going wrong with your system, maybe spare sensors, the ability to swap sensors, so that downtime is kept to a minimum. The last point there is you also need to include alarm annunciation. And QA people are going to be very keen on how the system reports. So basically, facility monitoring systems can monitor airborne particles, non-viable and viable. Previously we talked about non-viable with that. Room pressures and airflow. You can also measure temperature and humidity of rooms. And you can also monitor lots of equipment, such as fridges, freezers, and incubators. And within that, you can also, as well as monitoring temperature, you can monitor carbon dioxide and oxygen levels. I'm going to skip through this section because I think we've pretty much covered it on previous presentations. So, as with Matt, we're going to talk about some of the components on FMS software, on FMS systems. So first of all, you've got the software. Then you've got some kind of, you've got particle counters and or environmental sensors. So if you look here, you've got a particle counter with an integrated pump. Here you have a standard particle counter which we use a remote pump. Here you have a portable particle counter with an integrated pump. Here you have a temperature humidity sensor, and here you have a pressure sensor. You also, as previously spoken about, are going to need some kind of notification in the clean room, and this can be done via an alarm indicator panel, or you can use a fully integrated touchscreen PC. So you've got various options of particle counters that you can use in the facility monitoring system. The MET1 6000 series is for simple applications or where the particle counter will be installed inside an isolator or other equipment. We've got the 7000 series, which is, as Matt previously talked about, in a stainless steel enclosure. So it's pretty much ready for clean room environment. And you've got the 3400 series, which is a portable counter with the integrated particle counter. This is used for routine monitoring, classification of rooms, etc. And you may wish to upload that data into a facility monitoring system. So the 6015 counter in the guises that we use it is available with 1 CFM, 1 cubic foot per minute flow rate, and it measures 0.55 micron particle counters. And it also crucially measures the flow. Because it's all very well measuring particles, but if you haven't got a 1 cubic foot per minute flow rate, the data is no longer used to you. The device has 1,000 internal buffered results, which is important because it gives you some robustness against system failure, because data can be retrieved at a later date. Counters are easy to swap in and swap out when required. They have a 3-year warranty on the laser life, and they should last at least 10 years. And you can connect an optional temperature humidity parameter. The devices, as I said previously, are typically installed with isolators, and you can, if you wish, fix an optional arm stack to them, but this is rare. We generally fit these counters into a stainless steel enclosure to make them suitable for a clean room environment, so you can spray them with alcohols, wipe them down, etc. If you take the naked counter here and spray it with alcohol, it probably isn't going to last very long. With this type of enclosure as well, we provide a quick disconnect vacuum and a quick disconnect data cable, so that if the operator needs to take them out for calibration, or they need to be removed because you may choose to fit them in a different location, it can be done. You don't need an engineer to change it. We also have the 7000 series counter, pretty much the same as the 6015, except that it's already built into its rugged enclosure, and it does have a vacuum valve built into it. So, as Matt talked about different vacuum sources, you can connect it to a centralised vacuum system, and it can choose to stop and start the flow to the particle counter, or the vacuum to the particle counter. This sensor also, as opposed to the 6015, which is mounted inside a stainless steel box, gives you the ability still to connect your temperature humidity probe should you need to. So it's all very well having your particle counters in the clean room. Obviously the particle counters need a vacuum, if they're not an integrated pump solution such as the 6015, they require vacuum and data. So the easiest way to do this is to provide a wall plate for your data and for your vacuum here. And these are designed to pretty much look like a power socket on the wall. So you plug your vacuum and your data into your facility. You'll then have a mounting bracket where your particle counter hooks onto. So there's just a simple umbilical which goes in the particle counter to these connections here. Again, it's designed to keep it simple and straightforward for the operator. Got a couple of sort of different architectures we use. As Matt talked about previously, you have your PC here, you have your vacuum tubing and your data cable. This will run from the plant. The PC will live in an office area generally, and then you'll have data running into a plant room area, and you'll have vacuum and data which will run down the wall of the plant room to this socket, and as we said previously, fed by the umbilical to a particle counter. the same thing again, it's just a slightly different counter. We were using, previously we were using Ethernet, here we're using RS485. Don't want to go into that too much, but the only difference here is with Ethernet, each account has an IP address and the address stays with the counter. When we use RS485, what we do is we put the address into this wall plate here. It's a slightly different version of the wall plate we've seen just now, but that holds the wall plate. The address is common in these counters, so they're all set to address 0. So what that means, if you have a failure of that parcel counter, or you wanted to remove it for some reason, you can swap another one in without, and your data will always be mapped from that point to your counter. Whereas if you have an Ethernet counter and you move the counter from there to there, the computer thinks even though the counter is there, the computer thinks you're still monitoring at this location. So with the 485 connection, you put the address into this device here, so you're always sampling from where you think you are, no matter what parcel counter you put there. Just some more diagrams really of what we got on an FMS system. So we talked about, you've got a PC. There's another device we've now introduced which is called Watchdog. It's an optional item. What it does, it's constantly checking to see that the computer is operating and logging data. If this stops logging data, this will raise an alarm. The direct interface for parcel counting to the PC is a vacuum control panel. In this instance, we've got 4 individual pumps, a vacuum controller, and these vacuum pumps and controllers then link down to these parcel counters. Also, you'll notice that we've got connected here is an alarm indicator panel. Should we get an alarm, we will enunciate it on these beacons. These devices are configurable either to measure the whole system or specific areas. Here we're just showing somewhat, basically the idea of this slide here is to show you can put in a number of parcel counters at day 1, and should your facility be expanding, you can just simply add an extra vacuum panel on and add some extra parcel counters. So the flexibility of that is if you've got one aseptic suite in, you can add the second one later on to the same system. And again, another alarm indicator. And this time, what you've got is this alarm indicator will look after this set of counters, and this alarm indicator will enunciate for this set of parcel counters. So, we talked about non-viable monitoring. One of your requirements also, one of the gentlemen earlier asked us about viable monitoring. We can also offer a solution there. Previously, this has been done with a lot of handheld devices, but you can also do it continuously, and there are some advantages in doing that. With our solution for viable monitoring, the only device that sits inside the isolator or filling machine is this head here. It has an integrated impeller, it can be gassed, cleaned with alcohol, but everything else sits outside of the isolator, because obviously if you've got too much equipment in there, you've got no room to process. These devices can be sterilised and gassed in place, as I previously said. Air sample is drawn onto an agar plate. The impeller is underneath. And the critical thing that we do with these devices that other people don't necessarily is we monitor the sample flow. The standard says you have to monitor 1,000 litres of air. We see a lot of applications and air sample is put in. They say it monitors a certain flow rate. How do you prove it? You calibrate it once a year. But if you've got no reporting back, what happens when you come to a year and that flow rate found to be wrong? When did that flow rate go wrong? So, constants, we monitor the flow rate that's going through there. The device is also made, obviously, of 316 stainless steel, so they can be autoclaved and they can be supplied on the radiator plates. When we install active airhead samplers into you, we use a setup utility. And that allows you to choose some parameters that you want to do. So one of the things you can do with an air sampler is you can sample 1,000 litres of air in one sample, which is, depending on your sample rate, it'll take 10 to 15 minutes. Or you can decide that you're going to sample in stages. So you might want to sample before filling, or before your process, during your process, and after your process, to prove that basically you had a clean environment the whole time. So we can do that. We can say how long you want to sample for, what the interval is between sample periods, and how often you want that to repeat. So what that gives you is, say for instance, if you can spread that over sort of 2 hours or 2.5 hours of a total cycle to take place. Also, we calibrate the head for the flow, which monitors the fan speed, the current and voltage. And we can set alarm levels. So as we talked about, if the flow of the active airhead is incorrect, the system will report a fault to tell you that, because you want to make sure you capture that 1,000 litres of data, not too much, not too little. If you've not got enough air, you may miss viable particles. If you're sampling too much air, the danger is you could actually damage the agar plating. So the active airheads, as briefly stated, are put into the grade A zone. Here you'll see an active airhead. There's a tube underneath which you can fill it with a cable, and that will come to the outside of your container, be it an isolator or filling machine, is basically a filling machine. It's remotely controlled, and in this case we're going to use a delayed start. We're going to take a 1 minute sample every 15 minutes. And what that means is that we're going to take 1,000 litres over 2.5 hours. So the idea of this is, if your production run is going to take, say, 2 hours, you start this running 15 minutes before, start production, and then complete production, and you've proven that you've had no viable counts before production, during production, and after production. So it stops you having to make interventions and putting in different agar runs, basically. I mean, just sort of a bit of a name dropping, we've just done some work with GSK, and they are using this process in exactly that way. Over in England. So what we're going to do now is, we've looked at some simple system topologies. All we're doing here really is showing the same thing again. So you've got your computer, your control unit, your watchdog, your non-viable particle counters, their alarm annunciation, and now we're entering into the equation your viable counters. And this little device here, which is a module that does all the clever stuff with measuring the flow. It also detects actually when you've got a plate actually fitted to your sample as well. It's all very well having an active airhead sampler and setting it to run automatically. But if you haven't got your agar plate in there, you monitor nothing. Okay. And again, all of this data is fed back up to the PC where it can report for you. So we've also mentioned we can do a lot of pressure monitoring. If you're going to go to the expense of putting particle monitoring into an isolator, it's quite an expensive cost. In relation, room pressure monitoring or isolator pressure monitoring is fairly inexpensive. So since you've got the expense of bringing a system in, rather than rely on your magnetohelic gauges, which are fine, they tell you a pressure, they only tell you the pressure when you're actually looking at them. If you monitor them, it can cause more problems, but they monitor the pressure in time. Now obviously, when you measure pressures, one of the things you do is you put a delay on it. Because obviously, if you're going to be measuring the differential pressure between adjacent rooms, every time someone opens a door, it's going to go into alarm. So obviously you allow 90 seconds or 2 minutes to allow for people to walk through doors. And that's something that's tunable. What we often find with facilities is we set the limits from day one, and then we go back in a few weeks and we find out how they're getting on and we fine tune it. You can also monitor your HEPA filters. Again, you would generally do that with magnet unit gauges, but this system, if you do it automatically, A, you don't have to check it daily, and B, when you've got a problem, this system will tell you about it, it will tell you when you had a problem, and someone should, someone should take some action. The accuracy of the sensors is about 0.5%, plus 1% over range, and it's available in any range you want, really. Typically, if you're looking at sort of 15 Pascal changes, I would also recommend that you go for something that's had a plus and minus range, because if you've got a room and you're looking for a positive pressure of 15 Pascals, what you're really worried about is the airflow into that room. So as long as you've got a positive pressure of 15 Pascals, that's fine, and your alarm limit set at 15 Pascals, but the real problem you've got is when you get a negative pressure of, say, 5 or 10 Pascals, that's when you've really got to look at what's been going on in that room and potentially what the cause and effect would be. So it's worth considering. Often people only think about the actual limit and what they want to see. Sometimes you want to put something in that's going to show you the worst case scenario. As well as monitoring pressure, we can also monitor temperature, humidity. You can do that for rooms, obviously, and you can also do that. We do now a lot of monitoring inside incubators for biopharma applications and so forth, and sometimes inside isolators as well. We also have a quite a high-end, just using PT100s, we've got a very accurate IO module which allows us to monitor up to about 0.1 degree accuracy in temperature. Most systems can only claim to monitor to about half a degree, but we can go that extra step. Just on the temperature humidity monitoring, I sort of touched upon it. You've got a room probe, which is a single unit, but you can have one of these remote probes, which can actually be connected to the HAC particle counters, or they can be connected to a wall unit. And typically this is a probe that will then sit inside your incubator, rather than the whole device. They're typically accurate to about plus or minus 2% over a range, and that's between 0 and 90%. Actually, I think it's 0 to 95%, but obviously most sensors aren't very accurate from 95% to 100%. So it's something to consider if you're writing a URS to have a look at the manufacturer's data, because a lot of people put a specification of 0 to 100%, and unless you're going to spend a huge amount of money, there isn't a sensor out there that's going to do that for you. So we've got all of these environmental sensors. What we use is a range of IO modules which we manufacture in-house. Pharmacraft was set up by 3 directors who all came from the industry of manufacturing these data acquisition modules originally. Very, very briefly, we have a series of modules. We have a unit which provides 4 to 20 milliamp out inputs, temperature, RH, differential pressure, and 4 digital inputs, the door switches, or it could be equipment failure. One of the other things we do is work in the IVF industry, and they have some equipment which, as well as measuring temperature, it has fault conditions, etc. So we can just take an input there and say if it's healthy or unhealthy. We have an AI2800, which is just a 4 to 20 milliamp module with 8 inputs instead of 4 for measuring the same thing, 10 bar rate CTP, and air velocity. And we also have our PT2600 module, which is used for the high accuracy temperature measurement. So we use a lot of these in fridges, freezers, and incubators. And lastly, we have a CC2004, which again is 4 digital inputs, but it also has 4 digital outputs, which we can use to drive alarm tower stacks, fault-free contacts to other systems, and so forth, whatever you want to do with them, really. So So we just got another sort of system overview. It's exactly the same as before. You've got your particle counters, your watchdog counters, your pump control unit, your alarm. And this time, connected back to the system, you've got your environmental panel, which is gathering all the data for your temperature, humidity, pressures, air velocities, CO2, oxygen, whatever. Okay. So, as previously stated, it's all very well monitoring all of this data, but if there's a problem, you need to know about it. So, what you need is some kind of alarm indication. We do that via either a traffic light beacon stack, which you've probably seen, what we call an alarm message display, which we touched on briefly, via volt-free contact, the BMS, which is okay, but once you've got one alarm, that's it. It masks all other alarms. You can do it via a network, something like email, or via SMS pager and text messages from mobile phone. Or in these days, there is also the option to actually put a whole operating system on a mobile phone, but there are issues with validation of it. So, we have a very simple alarm indicator. We have a mute button, an LED which is either red, green or orange. Green being healthy, red being alarm, and orange being a warning. And then we have the same thing, only this time you have a 40-character display which tells you what's going on in the facility and what the alarm limit is you're breaking. In addition, both of these units can drive additional alarm beacon stacks, which you may, if for instance this is a large area, you may want the beacon stacks connecting in individual rooms. The alternative to this is that, as we touched on earlier, a PC with a touchscreen in the area. The main advantage with this, it gives the personnel in the clean rooms, if there's an alarm or deviation that's taking place, it means that they can actually acknowledge the alarm in the area. The other thing it gives you the ability to do is actually turn the particle counters on and off. Right, so we've touched on the hardware. We really need to look at the software that's associated with it now, because in terms of operators, this is, as far as a facility monitoring system is concerned, is all you're really going to see. So, the software is 21 CFR Part 11 compliant. It has comprehensive generic validation documents that go with it. It has compliant, non-compliant traffic lights. Its interface has European language support, so it can be standard, it's in English, it can be French, German, Turkish, whatever. And you also have some UNO support, so you can put computers, as we said, inside the areas. And as we talked about earlier, it also has active air support, but this is only for the individual PNP variant of the software. So when you look at the software, typically you've got an interface menu, and you have alarm indicators which tell you whether things are good or bad. You have a control panel to turn counters on and off, or to start them, or to stop them. There is a confirmation there, and it is, if not, you can specify what operators are allowed to stop the start particle counters. So not everybody can just move up and turn them on and off. You also have an export utility, so for those of you who like to export into Excel, you can do lots of fun graphs and so forth. And down here you have a list of all your current alarms. Hopefully your facility doesn't look too much like this, because there's quite a lot of alarms going on at the moment. And lastly, we have an audit log. An audit log is very important because it tracks things such as who's logged on off the system, who's changed alarm limits, what they changed alarm limits from, what they changed alarm limits to, and when they did them. And it also allows for further commenting. So, should there be a change control, because the system's been installed for a year, you've decided to change your equipment, you can put a comment in there, or you can say change control number, etc., etc. So it's you can print that out, and then you can add that to your change control to approve completed your process. It's very simple to configure and it's even easier to use. These little alarm indicators, go back a slide, these little alarm indicators here have a number of colours. Red tells you you've got a critical alarm, the yellow tells you you've got a warning, and you might want to take some action before it becomes a critical alarm. Green is healthy, cyan is for when there's a particle counter on there and the device is turned off, and this magenta or purple colour unfortunately tells you you've got a faulty sensor. And here, if any of these are flashing, that means it's unacknowledged. So typically you expect to see something red and flashing that's gone into alarm and it hasn't been acknowledged. But you could come in the morning and see something flashing green. And what that's telling you is your system's healthy now, but in the night time, maybe one of your pressures because your EMS system has failed or something like that during the night. It's just telling you you've had a problem. Talked about alarms. The operator can acknowledge alarms and put a comment in. That's done by clicking here on the alarm. You get a little drop box come up and you can acknowledge alarms either for multiple transitions or single transitions. And there is an option to have a standing comment put in there, or you can put a freeform comment. So something might be, we've got an alarm, we've taken the sensor out for calibration. But there is a utility here that perhaps if you have shut the clean room down, you've got someone who's logged on who's a manager level of the system, we haven't really touched on the different operator levels, but if you're a manager level of the system, you might want to, rather than acknowledge all the alarms individually, you might say, we've taken the clean room down, so we're doing maintenance. And you might just put a comment in to acknowledge all the alarms with a comment of maintenance by whoever, and then tag the user who's made that acknowledgement. So the system provides you with trends. You click the relevant alarm indicator to show the current trend. You can left click this point here and it'll display your alarm limits on the screen. So you might have a high limit and a low limit, particle counting obviously only high. And you can click the time base to say what period of time you want to look at the trend from. So you can put real time, historical, whenever you like. Everybody likes the trends, but actually the real thing that matters to you is your alarms. So when you produce something, you can very simply select the time base of when you produce the product over, and you can produce a reconciled alarm report. And this can generate all sorts of fancy things, but basically you look at a specific time period, and you might want to look at all alarms per alarm zone. Now, an alarm zone might be, if you've got a big system, might be a particular production area, or it could just be a particular room, or it could just be an isolator. You could decide that actually I want to look at all 5 micron particle counts only. So you just select 5 micron particle counts. That will tell you how many there were in the last month. Or you might just want to look at all temperature humidity sensors in the last month. It gives you the ability to pick and select what alarms you want to look at. Generally, you'll probably want to look at all alarms for the system, and then you can, if there are any deviations, you can write reports, etc. as to why. We also have a standard historical report, and all that is a log every 30 seconds or a minute of every value that comes into the system. It just logs it. Personally, I think the best thing it does is at the bottom here, it gives you a summary. So it tells you the number of samples taken, it tells you the mean, maximum, and median values for any values. So if you select it over the day, you know the temperature, you know your maximum temperature and minimum temperature that day, just on a simple 2-line. And you can choose to hide this raw data, so you get this simple summary at the bottom. Also got the audit log, which we talked about. And all this simply does is just logs who basically logs on and off to the system, and who makes any changes to the database of the system. And we talked about very briefly, you've got a data export utility. You just click the file, and it says, what period of data do you want to export to Excel? So exported data gives you separate tabs for data, alarms, you can see alarm comments in there, and audit problem. So an example of an audit problem is someone saying someone changed the scale from 0 to 1. From 0 to 1 to 20,000. So basically someone's changed the scale of the graph. Okay? So the reports offered include table of data, trends, reconciled alarms, audit logs, and importantly you get signature boxes in the bottom there, which you can pick whether you want 1, 2, 3, 4, etc. And you've got an optional batch reporting. And all the data is 21 CFR part and then white when it's on the system. Once you export it to Excel, you need your visual systems to back up what the data is, because once it's in Excel, you can manipulate it how you like, which obviously your regulatory bodies don't like. So the optional batch reporting allows trend, alarm, and audit log report to be automatically generated. And this is by a batch mentality rather than a time-based method. Switch which counters on environmental sensors will be included in the report because it might not cover the whole system. Select which reports are required. You want a trend alarm or historical data. And then you enter the start of this batch. And then you give it a batch code. And then you can save that into a PDF format and record it whatever you want. It's all very well having this software, but you've got to be able to prove to your regulatory authorities that you've actually tested it and proved it works. So we provide standard documentation packages for individual PMP, which includes the functional design specification, installation and operation of separate test protocols. The system is already validated at many sites, and the list is ever growing. It's important to say that individual PMP has a standard set of documents. We also have a product called Individual FMS, which is specifically tailored with hand-produced documents to suit the project. So it all depends on the scale and size of the project. Just to give you an idea, Pharmograph is supplied just a sample really, company called Demo in Greece. GSK Worthing, we've actually got an agreement to supply particle monitoring solutions to GSK manufacturing worldwide. MSD in Belgium, GSK in France, and Novartis is another big customer of ours. But we supply many, many customers. And in terms of global support, we've got a partnership which works with ourselves and Hat Langer. Installation service support is available by Hat Langer and their representatives. And then obviously we've got systems installed in the UK, Ireland, Germany, USA, France, Turkey, Greece, Spain, Switzerland, Portugal, India, Egypt, Romania, Denmark, Belgium, Indonesia. So we've got an ever-growing market. And just a list of some of the clients that we've supplied in the past. But there's a lot. Are there any questions? Thank you very much.